Okay, so here is a question that reviews looking at the normal curve and finding probabilities with the normal curve. Okay, meaning using your z tables and z-scores. Okay, so the example I give you, suppose the value of purchases made at a store follows a normal distribution with a mean of 22.5 and a standard deviation of 4.25. Okay, so when you see that terminology, that means that the first value is mu and the other value is sigma, the standard deviation. So answer the following questions, including the diagrams. Let x represent the value of a purchase. So what I did was I have these all worked out because this is the review question. So I have them all worked out, so I'm just going to show you the answers and then I'll make a few comments along the way. Okay, so this will only take a few minutes. The first one, find the probability that a purchase is less than 20. That's the probability that x is less than 20. So what you do is you convert your x into a z-score and then find probability. And what I like to say is you turn x into z into probability. Okay, so use your z formula of x minus mu over sigma. Okay, that's what z equals. And that's what always relates your probability to your x value, is whatever z is. Okay, so when you find your z-score, okay, you get negative 0.59 because you're doing x, the data value, minus the mean over the standard deviation. Okay, and that gives you to the nearest hundredth, okay, because you always round to the nearest hundredth. Your z-score is a negative 0.59. Okay, so the probability that x is less than 20 equals the probability that z is less than negative 0.59, which equals 0.2776. And remember, that value comes from when you shade your diagram, you put your 0 in the center because that's where the mean is. Okay, the mean is 0 standard deviations from the mean. So 0 is always in the center of your z-axis. And then negative 0.59, that'll be on the left-hand side of a 0. So when you look up negative 0.59 as a z-score, okay, negative 0.5 is way down here at the bottom, and then the 9 is all the way at the other end, which gives you the 0.2776 right here. Okay, so that is the area to the left of a z-score of negative 0.59. Okay, so that one is straightforward. Moving along to the next one, the probability that x is greater than 18. You do this in a very similar way, except the only difference is after you find your z-score of negative 1.06, after you find that z-score, so probability that z is greater than negative 1.06, it's greater than, so now you shade to the right-hand side. And what that does is, now instead of just looking up negative 0.106 and getting this 0.1446 area, you have to subtract it from 1 because you're shaded to the right-hand side. And remember that 0.1446, that represents the area to the left of negative 1.06. Okay, so that's why your answer is 0.8554. On the third one, now we're finding the probability that x is between two numbers. So you find the z-score for each of your x values. So that's why you have the 15 minus the mean over the standard deviation, and 25 minus 2250 over 4.25. So that's your x value minus the mean over the standard deviation again. So that gives you negative 1.76 and 0.59 for the z-scores. So the probability that x is between these two dollar amounts equals the probability that z is between these two z-scores. So on your diagram, you put your negative 1.76 on your z-axis, your positive 0.59 on the z-axis. You find the area for each of those. to the left. So when you look up 0.59, you get 0.7224 area. Remember, that's all the area to its left. So that includes from 0.59 all the way to the left. And that includes this area out here. Okay, that's it that you don't want. Look up negative 1.76, and that gives you 0.0392. So that's the area to the left of negative 1.76. Well, if you look at what we're looking for the shaded area. So you take the total area to the left of 0.59, which is the 0.7224, and subtract the area to the left of negative 1.76. And that's 0.0392. So you subtract those two areas, and that gives you 0.6832 for the area. Okay, and then on the other ones, now we're just going backwards. So when I asked you to find P90 and explain its meaning, so now instead of going from X to Z to probability, now we're going backwards. Okay, so instead of doing this, from X to Z to probability, now we're given the probability, or the proportion, that's to the left of our Z-score. Okay, so we know that P90 means that we have 90% to its left. So what you do is, you take that area, or probability, of 0.9000, you look that up in the body of the table. So 0.9000, and you get 1.28. So 0.8997 is closer to 0.9000 than either of these two other values are. So you use 1.28 for the Z-score. Okay, so in any normal distribution, Z equals 1.28 will have 90% of the area to its left. So that's where you use your formula again that relates Z to X. Your Z equals X minus mu over sigma. Plug in 1.28 in place of Z, and then solve that equation. Okay, and when you do that, you get 27.94, which means 90% of the purchases are less than $27.94. Go on to the last one, number 5, the IQR. So here the IQR is Q3 minus Q1. So you have to find Q3 and Q1. Well, the definition of the IQR is the middle 50%. So you have the middle 50% between Q1 and Q3. So that leaves you 25% on the left end, and actually 25% on the right end, which we don't really use. Okay, so what you look up is, if you look up either 0.75 in the body, 0.7500 in the body of the table, or 0.2500 in the body of the table, you'll see Z-scores of negative 0.67 or positive 0.67. So you plug those in separately into your equation for Z, and that'll find 19.65 and 25.35 for the X values. So to find the IQR, that is Q3 minus Q1. And that gives you 570 for the difference. Okay, so the middle 50% of the data has a $5.70 difference. Okay, so that is a review of the normal curve. If you need to go back and rewind the lesson or pause it, okay, whatever you need to do to see the answers.